Okay, so hello. This is your activity number 2. Okay, so this is your laboratory work number 2 because the laboratory work number 1, that is supposedly the tour to the laboratory, to our lab facility. However, you cannot do that. And actually, I changed that one to familiarizing yourselves in the laboratory apparatus or equipments by drawing this, okay, and researching on this. So this is your laboratory work number 2, reducing field sample to testing sizes. So you discuss on lectures that if you are going to make use of these materials, you need to test that one on laboratory. But of course, you cannot test all of these materials that you're going to use. What you're going to do is get a sample, and then that is what you will test on the laboratory. So the question there is, how are you going to get these samples? You are not just going to get that one and then use that one in the laboratory. You need to do proper way of reducing this field sample into testing sizes. So that is the objective of this laboratory work. Okay. So by the way, since you are by group, you do not need to fill up the names here, but you need to write down your group number. Okay, and then the date when you accomplish the activity. Okay, again, just like we discussed on the Zoom meeting, on the first Zoom meeting that we had, I am going to be the one to do the activity if I can do it myself, but if not, then I will be uploading a recorded video that is available on YouTube, okay, for your reference to accomplish the report. But since this succeeding laboratory work, I can do it alone, so I will be the one. I did this one alone on the laboratory, on our laboratory facility at the University of the Cordilleras, and it's up to you. You will make use of this video. Whatever data that I gathered, that will be the data that you will be using to accomplish the activity. Okay, so the objective of this is to understand the correct method of obtaining sample for laboratory use, and for mechanical analysis is an important aspect of material testing. Okay, so the purpose of this exercise is to obtain a representative sample for testing. So the reference here is your ASTM D702 and AASHTO designation T2-74. Okay, so these are the essential equipments and materials that we are going to make use in this work. Okay, so first is the representative sample of fine and coarse aggregate. Okay, a mixture of these, or it's either a fine or coarse only. We are just going to demonstrate how to reduce this into testing sizes. So spade or trowel. So since we are using small amount, so we can make use of trowel. Okay, containers, of course, and then 1-inch opening standard sieve. And then of course if we have this, but I did not show you this in the video, since this is a very big and I cannot bring it on the table. So however, if you can research this one, this is just a metal wherein you are going to pour the sample and that will be divided. So sample divider. So testing procedure, first is to from the stockpile of aggregates, take a representative sample of sand and gravel, place the materials in containers separately. Or in this video, what I did is that I get a raw aggregate wherein it is not yet separated into fine and then coarse. Okay, so that is what I did. But again, in case you are just testing fine, then you can just get fine. If you are just testing raw coarse, then you will just be getting the coarse aggregates. So wash it thoroughly with water so that it will be free from silt or clay. Okay, we discuss on the lecture, or that you discuss on the lecture, what is the effect or what is the reason why we are trying to get rid of silt or clay on the aggregates that we will use on concrete mixes. Okay, so since these aggregates are used on the laboratory, these are having silt or clay, but they are almost negligible. The amount is almost negligible. So wash it, or so that will be free from this, or if that is negligible, then it's okay. So set the sample to air dry condition, since again that is already there in the laboratory, that is already dry. So number 4 is pass the sample in sieve number in 1 inch and disregard the sample which is more than 1 inch in diameter. I already did that, so that is not included on the video. But in case you just gather that raw aggregate from the stockpile, then you need to do this. You need to screen that one, and you will consider those that will pass the sieve with opening 1 inch, and then disregard the 1 inch and above. And then make a conical mound, flatten it with trowel, and divide into 4 parts. Take the opposite division for mechanical analysis of aggregates. Okay, so that is what we are going to do. Try to mount a conical shape, flatten this one, divide this one into quarters or 4 parts, and then get the opposite quarters, and that will serve as your sample size. If that is still a lot, then you need to repeat the process up to the time you will reduce this one into the desired amount or into the desired sample size. Okay. And so you will see that one on the video. That is what I did on the video. And then number 6, in case a sample divider is available, pour the sample into divider and retain the sample poured in one side. The sample will be used then for sieve analysis, colorimetric test, and for preparation of concrete specimen. Or that means that is what you're going to use for as a sample, okay, to be tested for mechanical properties. Okay, so again, in the next video, that is what I did. However, again, I did not use the mechanical splitter or the sample splitter. Since again, that is simple, all you need to do is pour, that will segregate. But for manual, that is your quartering. We call that one the quartering. Mount that one into conical shape, flat that one, divide it into 4, and get the 2 opposite quarters. Okay, so that is how we will reduce into sample size. So in this laboratory work, try to watch the video, what I did on the video, and then based on what I did on the video, try to come up with your report. Okay, first is to illustrate the method of quartering. That is what we call the quartering. That is the manual, as a method of reducing field sample to testing sizes. However, okay, again, the significance, that is the second significance of these 2 methods. However, again, as I've said, I did not did this sample divider. But again, the purpose is the same, to reduce from a large amount to a sample testing size. So again, the 2 methods that is referred to in this report number 2 is the manual, which is the quartering, and the sample splitter or divider. Okay, so that is what you are going to accomplish in this laboratory. So again, this will be your front page. This will be your front page. You will have there your group number, the date performed, and then of course watch the video, and then you are going to come up with your report. So here comes the video. Okay, so this is the sample, okay, that we gathered from the stockpile of aggregates. So it is a mixture. Okay, it's up to you what you are going to test, if it is a fine aggregate or a coarse aggregate. But for this case, this is a mixture of a coarse. It is still a raw aggregate. Okay, it is not separated from fine and then coarse. So we have here your pan. This is the pan, of course, and then we have here your 1 inch sieve. This is what we're going to use to screen. If there are larger sizes than 1 inch, we are going to disregard that one. And then we have here your trowel. Okay, since we have only smalls, we are doing this one into a small scale. Okay, we are doing the experiment in a small scale. Since we are using a small amount of aggregate, then we will be using trowel. But of course, in the case that you are using or you are doing it in a big scale of this experiment, then you will be needing a lot of this sample, and then of course you will be using spade. So what I am just going to demonstrate to you how we are going to reduce a stockpile of aggregate into a sample size. Of course, is for you to gather or to get a sample from a stockpile, and then what you're going to do is form that. Try to use a trowel or spade to form that one in a form of conical shape. Okay, conical shape. Okay, by the way, it is stated there that the sample should be free of moist, so it means that should be dried, and then of course your sample should be free of silt or sand or soil. Okay? Again, that is discussed in your lecture. So let's say that is just the small scale of the sample. But if you are considering a bigger scale, then you will be having a lot of this. So first is to put it in the form of cone, and then once that, what is the reason why we are putting this one in the form of cone? So that once you will drop the sample, it will be distributed all around. Okay, so that the distribution will be equal. Now we are going to flatten that one. Okay, flatten that one, of course. Flatten. Okay, flatten this. And then it says there we are going to divide it into quarter or 4 parts. So let's say that will be our division. Okay. So what are we going to do here now is, let's say you want to reduce this one into a smaller sample. Now get the opposite side. So opposite of this 1/4 of the total. So I will be removing, okay, the others, and then I will be considering these opposite sides as the sample. Okay, so let's say you have there another pan. So all you need to do is get this one and transfer. That will serve as your sample size. But again, if you are considering a bigger scale, then you will be having a lot of that. Okay, so that's it. We remove the opposite part, and then we will consider that as our sample. Okay, that we are going to test the mechanical properties. Okay, so again, the objective of this procedure is for you to reduce from the bigger amount of sample to a smaller amount of sample. Let's say that is what you only need for the analysis of the chemical property of this aggregate. Okay, so that is our experiment.